Hi everyone, today we are going to review a little first and then we're going to move on to section 2.2, systematic, stratify, and cluster. And we're also going to review simple random sampling, and we're going to add one more is the convenience. Start off with example 1. A college employs 30 full-time faculty members. The president of the faculty union wants to obtain a simple random sample of 5 of them to survey regarding contract negotiations. The first question says, do we want sampling with replacement or sampling without replacement? Because we want to take the survey, we definitely want to have sampling without replacement. And just a quick review, without replacement means you don't replace with anything. So in this case, the numbers or the person will not be repeating or doing the survey twice. How many objects is in our list? Well, there's 30 objects in our list. And how many numbers do I need to generate? Simple random sample of 5 is what we need. Use a random integer generator in your calculator or computer. What the 5 members would be in the sample. So go ahead, write your number down. Compare your 5 numbers with the other in your group. Do you all get the same numbers? Don't forget, if you seeded, you will get same number. And if you don't see, you will not. I will put that down for you just in case. If you seeded, you will get the same numbers with your friends. If you don't seed, you will not get the same numbers. Please make sure you listen to the next paragraph. It says, samples generated randomly will have different individuals, which in turn will likely result in different value of the descriptive statistics. Description about the group you sampled. One last thing, no matter how well you plan and carry out the sampling process, there will likely be some errors in the results. We need to keep in mind why we take samples. We take samples to make inferences about the population. It would be nice if those inferences that we draw later are as accurate as possible. But when you use smaller group of items or individuals to try to understand some characteristics of the population, it is unreasonable to expect the information in the sample to tell a complete and accurate story about the population. So in this case, they are also saying you need to make sure your sample group is big enough. 2.2, systematic, stratify, cluster. Those are the different types of sampling. We talked about the simple random sampling in section 2.1 already, and just a quick review, we done the examples from before. The goal of sampling is to get as much information about the population as possible, usually as quickly and as cheaply as possible. For some studies, collecting a simple random sample is difficult or impossible. In this section, we will discuss 4 other ways to randomly select individuals. Number 1, systematic sampling. Number all of population sequentially. Then from a starting point, select at random. Include every case member of the population in a sample. There is a pattern when you use systematic sampling. For example, when you make the phone or any candy, there is a sampling line that the product will come down. And then so you're going to pick every 100 or maybe every 10, but it's going to be a pattern that they check every 10. There's a pattern to how they pick their product. So make sure you keep that in mind. And that is how you relate systematic. Next one, we are going to find the spacing in between each product is pulled. So find the spacing between each samples. Number 1, determine how many samples you want. We're going to use a little n. You want from the population of an object. That's going to be the big N. And then we're going to do a big N divided by little n. So that means the population divided by how many sample you want. Then what you're going to have is you are going to pick a random number between 1 and n term, and the number is k. That's the spacing. Count every k object off from the population using your samples. Number 5, should always round down when calculating k. The reason we have to round down is because if you round up, you are going to run out a sample cover the last k samples. So first example we are going to look at is, let's say you have 550 objects and you want a sample of 30 of them. So how do you find the space? We are going to take 1, the big N, which is 550, divide by 30, and the answer is going to come out to be 18.3 repeating. Because it's a 0.3, we are going to drop that because you are not going to have enough spacing to cover the last set of samples. So we are going to have every 18th object will be a sample. Second type is called cluster sampling. You have to have a group of individuals in a population that's located near to each other. 2, work best for practical reasons like saving time and money. Next one, the cluster looks like the population but smaller scale. And then the last very important thing, please add it in there. We are going to test, or we are going to sample every single person in that cluster. Everyone or all in that cluster. So we might pick one cluster, we might pick 2 clusters, but every time you pick a cluster, every single cluster is going to be sampled. So, or take a survey. So now let's take a look at the examples. Example number 2 says, a survey of school children in a large city. We could first randomly select 5 schools and then include all the children from each selected school. So first of all, if you think about it, the school children in a large city, we are putting in school situation. That means that they have the same kind of population, but just in a smaller scale because they want to talk about school children. And then it saves money and times is because you don't have to run around, and then includes all the children from each selected school. Each selected school, that's your cluster. So let me put that down. And then you have this small population. So don't forget all the keywords. Small, same population, all is same thing as every, and each selected school is each cluster. So that is cluster sampling. Number 3, stratified or strata sampling. Number 1, groups of individuals in a population share the same characteristics thought to be associated with the variables being measured in the study. So the characteristics they have to share and is related to what they are being measured. Number 2, work best when individuals within each stratum are similar with respect what to being measured. Okay, and then the next one, large difference between strata. So what happened is the strata is going to be things like a same kind of category. So for example, freshmen, sophomore, juniors, and seniors, and each group has a very big difference. For example, freshmen probably sleep more because they have no cars, they have no jobs. On the other hand, seniors who has a car, who has a job, they probably are out late at night, and so they probably sleep less. So those are the things is the people in that group has a very similar characteristic. Okay, all right, work best when individual within each strata are similar. Right here, individual within each strata are similar. The next one, large difference between each strata. So in this case, freshmen, sophomore, juniors, and seniors are totally very different. Then the way we pick them is, I'm going to add it in, is we use simple random sampling to pick people out of each strata. Let me write that down. What they are saying is the last one. We use simple random sampling to pick samples out of each strata. So we are going to separate them into same characteristic of a group, and then we're going to use simple random sampling, which is put everybody's name in the hat and pick, and then get the samples out of that. So it's going to be like a freshman group, and then you're going to put everybody's names in the bag and pick, and then you're going to put sophomore, everybody in the bag and pick. Okay, so that is going to be stratified sampling or strata. Number 4 is convenience sampling. Convenience sampling's rules are selects individuals from the population who are easy to collect and do not bother with collecting them randomly. You just whatever is the easiest. Convenience sampling often produce unrepresentative data. That means certain data is not going to be counted for. Then the next one, sample will usually not represent the population well. Here is one of my favorite one, taking survey at the Starbucks about how much individual like coffees. A lot of people going to Starbucks is going to like coffee. So your coffee survey, how much do you like coffee, is not going going to be the representing of the whole population of everybody who drinks coffee or not drink coffee. So those are your 4 samplings that we learned for today that is new. So here's a little chart just to give you some ideas to summarize them. Simple random sampling, that's what we learned before. We put everybody in the hat. Stratified samplings put everybody in the same type. For example, freshmen, sophomores, or seniors, juniors, and just randomly pick them. Then right here is systematic, every 3 or different number. This is every 3. Systematic is every 3, every 10, every 20, every 100, every 1,000, but it's always have a pattern of every. Maybe that will be helpful. Then cluster is going to be everybody have a small of same type population, same. Then we are going to take all small groups, and that's most important thing. So make sure you understand the difference, the 4 different types of sampling. And don't forget, convenient is just going to be whatever is the easiest, just asking people at the Starbucks coffee place. So I would like you guys to try the first 4. I would like you to try the first 4 questions. Please pause the video and try the first 4 problems. It says identify whether the sampling method is simple random, systematic, stratified, cluster, or convenient. And then they want you to explain. So I'm going to just highlight them. Number 1, a researcher randomly select 20 Taco Bell locations and survey all the employees in those locations. 20 Taco Bell is very similar, okay? And then you have all the employees in those locations. So therefore, it's going to be cluster because you are picking the same type of situation establishment and picking all from each Taco Bell. Number 2, news station hosts a call-in survey about whether physician-assisted death should be legalized in all states. That's just a convenient because it's call-in, and then whoever didn't answer or whoever didn't get a chance to be called, you don't get their idea. So that's not quite the best survey, because a lot of time people who are older is going to be the ones on the phone if the telemarketer is calling in the morning. So that's number 2. Number 3, it says a researcher randomly select an LED TV out of 20 first 200 LED TVs on the assembly line, and also select every 200. Number 3, a researcher randomly select an LED TV out of the first 200 LED TV on an assembly line, and also selects every 200 LED TV after that. That's going to be systematic pattern. In between them, the K value, which is the spacing, is 200. So every 200, they're going to pick one. So that's why it's systematic. Next one, number 4. Oh, let me highlight that for you, and then select every 200. Next one, you have in a study at a community college, 30 instructors are randomly selected from in a study at a community college. 30 instructors are randomly selected from full-time instructors, and 50 instructors are selected from part-time instructors. And this is going to be stratified because we are 30 instructors randomly select full-time instructor, 50 are selected. It didn't tell you how, so it's just random sample. It tells you right here. So therefore, it's going to be stratified because they are separated into 2 groups. One group is going to be full-time, the other group is part-time. So they are similar situation, and they are picking it randomly from each group. So those are the 4 examples. Give it a try for the rest of it, and we can discuss it in class. This is the answer for the 4 examples. Thank you so much for watching.